Now we have what's called the ambiguous case of the law of sines. And what I usually like to do with this section is I just let you go ahead and try this first problem. There's really no difference between this problem and the ones you've already completed other than the information that you've been given. So just go ahead. See what happens with this problem.
See you later.
All right. Anything weird happen?
Negative.
What's negative?
On that one.
First, let's see if we have our triangle labeled correctly. We changed 55 degrees, 40 minutes into 55.67 degrees. Side B, 8.94. Side A, 25.1. So if we dive right into this problem using the law of sines, you would have to try to figure out angle A first, right? So you would say that 25.1 over the sine of angle A equals 8.94 over the sine of 55.67. So this time we're actually solving for sine of angle A. So the sine of A would equal 25.1 times the sine of 55.67, divide that by 8.94. And look what happens when we take 25.1 times, let me put that in parentheses, 25.1 times the sine of 55.67, and then divide that whole thing by 8.94, we get 2.319. So the sine of angle A, 2.319. So now we're going to try to come up with an angle whose sine is 2.319. Now some of you can maybe just look at that equation and say, nah, you're not going to fool me. Or look what happens on your calculator. If you ask the calculator, hey calculator, inverse sine 2.319. What's it going to give me? Burp. Why is that? It's because the sine always has to be between 1 and -1. There is no angle whose sine is 2.319. So since no such angle A exists, then you can simply say no such triangle exists. No triangle exists. You can't cause these three segments to all join at one point given the information that you have in that problem. Just can't do it. So again, the ambiguous case means something weird could happen. In one case, you might have the case where you simply can't create a triangle. I wonder what else could happen. Suspense is killing me. See what happens with this problem. Let's label our triangle. And angle A, 55.3. Side A, 22.8. Side B, 24.9. So we can begin this problem by finding angle B, right? So we'll say 24.9 over the sine of B is the same thing as 22.8 over the sine of 55.3. Correct? Right? This is how we all started this problem. And now we find out that the sine of B is equal to, when you multiply those two together and divide by 22.8, you get 0.89787. So far so good, right? And then when we ask our calculator, what angle, inverse sine, making sure our calculator is in degree mode, inverse sine 0.89787, we see that that angle is 63 degrees, 63.88. So let's put over here, angle B is 68.88. 63.88, I'm sorry. Now, using that for angle B, let's see what else we can find. Well, we have angle A. We just found angle B. Now we can come up with angle C. So we'll take 180 minus B, angle B, 63.88, and minus angle A, which is 55.3, and we get 60.82. So I got my three angles. I need one more side. We need to figure out what side C is. So we got to use the law of sines one time. C over the sine of C, sine of 60.82 equals, and here it's up to you. You can use A and sine A, B or sine B, whatever you'd like to use. You'll get the same answer. So I'll use B, 24.9 over the sine of angle B, which we found to be 63.88. And we use our law of sines, multiply together, divide by sine of 63.88. We get C is equal to 24.21. Right? There's the two missing angles, and there's my missing side. Anybody have any comments about what just happened?
Go up again.
Well, wouldn't there be two solutions?
Bingo! Because of this right here. Here we're seeing that the sine of this angle is positive. And there are two quadrants where the sine is positive, quadrant 1 and quadrant 2. So what other angle out there also has a sine of 0.89787? That'd be the quadrant 2 angle. You found the quadrant 1 reference angle right here. So if you take 180 minus that angle, you'll get the other one. So there's actually two possible triangles involved here. Your other possibility is that angle B is equal to 116.12 degrees. Before I continue on, do you see why there's two possibilities for angle B?
No, can you go over that again, please?
The sine of angle B is positive.
Okay.
There are two quadrants where it's positive, quadrant 1 and quadrant 2. Here's the quadrant 1 angle. Here would be the quadrant 2 angle, which I got by taking 180 degrees minus this one.
Okay.
And now, folks, to finish the right-hand side of squiggly line, we'll do the same thing we did on the left. How did I get angle C? I add them together, subtract from 180. So angle B plus angle A, subtract that from 180, gives us another option for angle C, being 8.58 degrees. Then to use the law of sines one more time to find side C, we would have C over the sine of our new angle C, 8.58, is equal to 24.9. Over the sine of angle B, which is 116.12 degrees. We have an alternative answer for side C, and that is 4.14. So we just went from a situation where there was no such triangle to a situation where there are two such triangles exist. It's possible to construct two triangles that satisfy this situation. Gee, I wonder what options left. We went from none to two, right? I wonder if it's possible to only end up with one triangle. Let's find out. Example 3 says solve triangle ABC given the following information. So we'll start with a picture. A, B, C. A 43.5. 10.7 and 7.2 for C. And with the information that we have right now, we really don't have a choice. We got to find angle C first. So 7.2 over the sine of C equals 10.7 over the sine of 43.5. So we'll get sine C. You should get sine C is equal to 0.46319. So far it doesn't look like there's any difference between now and what we did in the last problem. I got this sine, it's positive. So I should end up with two angles, and we will. Let's do the quadrant one angle first. If you ask your calculator inverse sine 0.46319, you'll get an angle C of 27.59. Let me just verify that. Inverse sine 0.46319, 27.59. So there's angle C. I have angle A, so we'll add those two together, subtract from 180, and we get an angle B value of 108.91. Need to use the law of sines to find our missing side, and that missing side would be side B. So B over the sine of angle B, which we just found to be 108.91, equals, take your choice, pick a side, doesn't matter to me. You can pick 7.2 over the sine of angle C, which is 27.59. And when we solve that proportion, B is equal to 14.71. So again, so far it doesn't look like there's any difference between what we've been doing in this problem and the last problem. Here's one possible solution. Those two angles and this missing side. Now look what happens on the other side. What is an alternative angle to angle C? Well, what would be the quadrant 2 angle with a reference angle of 27.59?
152.4.
152.4. Well, let's come up with angle B then. What happens? When I add these two together, C and A, I'm over 180. Which means angle B would have to be a negative angle. Ain't gonna happen. So you can stop there. This situation can't happen because your angles will end up being more than 180. So there is only one triangle solution to this problem. So with the ambiguous case, you'll never know until you actually get halfway through the problem, right, if there's no triangle, one triangle, or two triangles. Okay? Questions? Get really, really good with law of sines before I start throwing law of cosines at you on Monday.